factor. Okay, greatest common factor. Number 5 asks us to factor the polynomial completely. Okay, but before we factor, well, let's see. There's a couple of things that we're going to do here. Before we can factor completely, we have to find the greatest common factor. Now, you've seen this before, but I'm trying to figure out the best way to describe this. The greatest common factor is what each of these monomials are divisible by. So if I have here x cubed, this is number 5, minus 2x squared minus 24x. Again, you should know how to do this. So if I go too fast, let me know. You might have forgotten how to do it. You might need a little explanation, but I'm assuming that you've seen this before. It's not like nothing against you. If you've never seen it before, that's okay. Just got to make sure you know how to do it. But I'm going to teach it very quickly to make sure that you've seen this before. But first, we've got to figure out the greatest common factor. I see that these all have an x in them. Okay? They have at least one x in them. So that means I can factor out 1x. Let me go back. What does the word factoring mean, by the way? And you know what? Like when you're saying factoring polynomials, sensei, what the heck does that mean, right? So I'm gonna look at you guys. See, do you guys know what factoring means? I know you can see. Let's go with let's say Jade. Do you know what factoring means, Jade?
Taking it apart.
That's a good way to put it. That's a good way to describe it. More specifically, I would say factoring is the opposite of multiplication, but it's not really division. It kind of is kind of division, but it's the opposite of multiplication. So let's do a quick Godzilla time. Let me just play around here for a second. Let's say I have x, you don't have to write this down, x plus 3 times x minus 2, right? And I said, hey, multiply those to binomials. And you would go, hey, x squared, x times 2 is negative 2x, 3 times x is 3x, 3 times 2 is negative 6. So it's x squared plus 1x minus 6. Okay, so we went from here to here, that's multiplication. But if I said to factor it, all I'm telling you to do is to go from here to here. If I said, hey, factor x squared plus x minus 6, it means I go like this. Hey, I multiplied it, but factoring will tell me x plus 3 times x minus 2. That's factoring, okay? You're going from there to there, okay? So that's what we're going to do today. Now, the other thing of factoring is, let's talk about the greatest common factor again, greatest common factor. If I said this, let's say I said 3x times x squared plus 2x plus 1. And I said, okay, multiply. How would I multiply this? What property would we use? Let's go with Malia. What property would I use to multiply this? I'm multiplying this right here. Multiply. This is all review. If I wanted to multiply this, Malia, what property? I don't know if you remember it, but if you remember the name of that property we'd use to multiply that 3x?
Hold on, let me check my notes.
No, I'll give you a hint. Can I give you a hint?
Yeah.
It rhymes with distributive property.
I don't know.
Did you hear my hint? Did you hear my hint, Malia? Did it help you?
No.
Okay, hang on. Let's see if someone else got my hint. It's okay, Malia. Let's see if someone else got my hint. It rhymes with distributive property.
Oh, wait.
Max, what property would I use to multiply that out?
The distributive property.
Yes, there you go. It does rhyme with distributive property. Malia, have you heard of the distributive property?
Yeah.
Yeah, okay. I thought you did. So the distributive property, I got to distribute. 3x times x squared is 3x cubed, right? And then I got to distribute the 3x to the 2. Remember, this is Godzilla time. You don't have to write this down. 3x times 2x is, I got to multiply 3 times the 2, and I get 6. And then the x times the x, I get x squared. And then multiply this, I go, boom. 3x times 1 is 3x. Now, I multiplied, okay? But we're talking about factoring. Now, if I asked you to factor this, and I said, what is the greatest common factor? You want to find something that these are all divisible by. Now, by the way, some of you already know what the greatest common factor is, but the greatest common factor is what can I divide this, this, and this by? Well, you know what it is? What is the greatest common factor between those three monomials? Let's go with Seth. What is the greatest common factor here? Greatest common factor.
3.
Yep, but there's another one. That's a factor. It's not the greatest common factor.
Oh, 6?
No. Don't change the 3. Now
Oh,
I'm
3x,
confused.
yeah.
What's that?
3x.
Yes, it's 3x. All of these, because by the way, you can see it, it's here. I multiplied by 3x. I can also I can divide all of these by 3x because they have at least one x and they're all divisible by 3. And then you take the 3x out and divide it. 3x cubed divided by 3x is x squared. 6x squared divided by 3x is 2x. And 3x divided by 3x is 1. This is factoring, okay? If I say find the greatest common factor, this is factoring finding the 3x. And then, just curious, I need to look at you guys. This right here, x squared plus 2x plus 1, I'm going to write it right here. X squared plus 2x plus 1, okay? Give me one of these. I need to know if you guys know how to factor that. Give me one of these things like, hey, sensei, I already know how to factor that. I don't even need to be taught. Give me one of those if you know how. It's fine. I just want to see where I'm at here. 1, 2, 3. Okay, 4, 5, 6, 7, 8, 9. Sorry, you can see me looking at your. Okay, so like less than half. Okay, so real quick, I'll go over factoring that in just a second. Let's do number 5, and I'll show you with number 5. Okay, so Godzilla time is over. Okay. Number 5 asks us to factor this completely. Now we got to find the greatest common factor, which we already talked about. What is the greatest common factor here? Let's go with Ishi. What's the greatest common factor there?
X.
Yeah, they're both all divisible by x, so I can take out an x. Imagine in my mind I'm dividing each of these by x. X cubed becomes x squared. 2x squared becomes 2x. Negative 24 becomes negative 24x, and it becomes negative 24. Okay, so I factor out the x. Now, I want to be able to factor this out. Okay, there's a couple things. Wait, let's see if this is factorable. It is factorable. Here's how I do it, okay? I use what I call the diamond problem, even though I draw the x. But what I do here is, you guys should have seen this in math too. So I know you did this a ton in math too. You put the negative 24 up here and the negative 2 there, okay? And you need to tell yourself, what are two numbers that I can multiply and equal negative 24? And then I can add and they equal negative 2. Okay, what are the two numbers? Okay, what are two numbers that multiply equal negative 24 and they add and equal negative 2? Let's go with Virginia.
I'm not sure yet.
Okay. Well, what are two numbers that multiply and equal 24?
Oh, 12 and 2.
Yes, very good. They're 12 and 2, but it's got to be a negative, so one of them has to be negative. Oh, but that doesn't add up to 2. Good try. Are there any other numbers that multiply and equal negative 24, Virginia, besides 12 and 2? Are you there, Virginia?
What?
I was asked if you were there.
Oh, yeah. Sorry.
It's okay. What are another two numbers that multiply and equal 24 besides 12 and 2?
Sorry, I can't think right now.
Okay, that's fine. You gave me one. That's good. Let's go with Madison. Two numbers that multiply and equal 24 besides 12 and 2.
6.
6 and what?
4.
Okay, which one should be negative in your opinion? Or do you know? Maybe you know or guess. Give me a know or a guess. Which one of those should be negative?
6.
6, okay? Because negative 6 times 4 equals negative 24. Negative 6 plus 4 equals negative 2. So this factoring completely, how you write your answer, x times, this is a negative 6, so I write as x minus 6, and this is a plus 4, x plus 4. And that's your answer for number 5. Okay, let's move on. I'm moving on. Let me know if I'm going too fast. Let's look at number 9. Should I do 9 or should I move on? I feel like we don't want to spend too much time on this. Okay, there's something called the difference of squares, which you need to know. Difference, this is notes, of squares. Okay, here's the difference of squares. Here's how it works, okay? Difference of squares is exactly what it sounds like. Like, for example, a difference of squares would be x squared minus 25. I know this is a difference of squares because this is a perfect square and this is a perfect square. And I'm subtracting them. Difference of squares. Every time you factor the difference of squares, the answer is going to be this. Watch this. What's square root of x squared? X. What's square root of 25? 5. And then you put a plus and minus. That's how you factor the difference of squares. Let me do another one. Sensei, you're going so fast. I know. Okay, let's do another one. Let's do x squared minus 49. That is a difference of squares. Here's the answer for x squared minus 49. X square root of x squared is x, square root of 49 is 7. 7, you put a plus and a minus. Let me do one more, okay? Here we go. Your sensei going so fast. And just watch. You don't have to write it down. Or maybe you do if you don't understand the pattern. Let's do 16x squared minus 81. This is a perfect square, 16x squared. This is a perfect square, 81. Difference of squares is going to look like this. What's square root of 16? 4x. Square root of 16 squared again is 4x. What's square root of 81? 9. 9. Answer? Minus plus. It doesn't matter if you put them plus or minus, but that's how you do the difference of squares. So looking at 7, even though I told you every other odd, I'm still going to do 7 because it has a difference of squares 1 on it. Let's do 7, which I have here. 7, you can write this down. 3p to the 5th. I'm going fast because I'm assuming you guys know how to do this. 192 p cubed. Greatest common factor first. These are both divisible by 3. I don't know. What's 192 divided by 3? Do you have my calculator with me? 192 divided by 3. What is that? Come on. I don't want to. Let's see. 192 divided by 3. If someone knows it before I calculate it out, I don't know.
64.
Thank you. 64. So I take the 3 out. The 3p cubed. Take out because they have 3 p's in each of them. So this becomes p squared minus 64. That is a difference of squares. This p squared minus 64. So our answer is going to be this. 3p cubed times, what goes in there? What goes in there? Let's go with Irvin. What goes in there, Irvin?
It's p plus 8.
Keep doing it. You got it.
P minus 8.
Yes, okay. Whew, that echoed. You survived the echo, Irvin. Thank you. Okay, p plus 8, p minus 8. That's it. Do you have 2 computers on or something, Irvin? Okay. So that's 7. You can do 9. Let's see. We did 5, 9. Okay. Now there's something called, hang on a second here. Let me see here. Let's see. There's something called the sum of cubes and the difference of cubes. Okay. So the sum of cubes is going to be, here's the sum of cubes, okay? So write this down. This is something important. You need to have this like in a good spot of your notes. Sum of cubes. Okay, the sum of cubes is this. Oh, hang on a second here. Okay, it's sum of cubes. You have a cubed plus b cubed. Okay, so, oh, sorry, it's not. A cubed plus b cubed. Let me move this over here so it's more comfortable. There. A cubed plus b cubed. So like a sum of cubes. I have a cube and I'm adding a cube. Sum of cubes is a cubed plus b cubed is equal to this. A plus b times a squared minus ab plus b squared. Make sure you write that down. As with the difference of cubes, there's a sum of cubes and then there's a difference of cubes. You have the difference of cubes, which is, here's the difference of cubes. A cubed minus b cubed is going to equal a minus b times a squared plus ab plus b squared. Make sure you have those written down because that's going to help you with number 13. And then 15 is also the difference of cubes. 17 is the difference of cubes. So we'll do 13 and 17 together. Okay? So make sure you have those written down, sum of cubes and the difference of cubes. Okay, so we have here 13. Can I move it? Do you guys need, I'm gonna take this away unless someone says in 10 seconds. I'm gonna remove it from my screen in 9. Unless someone says 8, 7, 6, 5, 4, 3, 2, 1. Okay, let's do number 13. Okay, 13 is x cubed plus 64. Was that a sum of cubes or a difference of cubes? Let's go with Clara. What do you think? Sum of cubes or difference of cubes?
Sum.
Very good. So 50-50 chance. So sum of cubes, again, I'm going to write it down here, is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Okay, now here's the $1 million question. If I'm doing a cubed plus 64, what is my a going to equal and what is my b going to equal? Ariana, what do you think? What if I have x cubed plus 64? What do you think my a would be in this? It's kind of a hard question, sort of. I don't know.
I think it would be x.
Yes, very good. It's going to be x because once if I cube that, it'll equal x cubed. So what do you think the 64 will be?
B.
Yeah, but what will the 64, what will b be for 64? Is there a number I can cube and make it equal 64?
Oh,
I guess.
I don't know.
it's actually going to be 4. So A is going to equal X, and B, Ariana, is going to equal 4, because 4 times 4 times 4 is going to be 64. So you want to take the cube root of this, and that'll be your B, and the cube root of that, that'll be your A. Okay? So now that I have that, we just mirror this. So I say it's A plus B. So my A is X, my B is 4. So it's X plus 4 times A squared. What's this squared? X squared minus A times B. A times B, let's say 4X plus B squared, 16. And that's all you got to do. I'm moving on. Sensei, you're going too fast. I know. Let's do 17. Here we go. 3h to the 9th minus 192h to the 6th. Okay, you guys looking at that? You looking at that? Here's what I want you to do. I want you to go ahead and find the greatest common factor. Go. What's the greatest common factor there? GCF. Go. I'm going to call on you. Greatest common. Greatest common factor. When I get back. I'm coming. Tell me the greatest common factor. What is it? Boom, 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 boom. What is the greatest common factor? Greatest common factor, 3h to the 9th, 192h to the 6th. Let's go with, oh, Eric's here. Eric. Eric Jones.
Yeah.
I think it marked you absent.
It came late.
Okay, remind me after class because you're marked absent, so remind me after class to change it. But what's the greatest common factor, Eric Jones?
3.
Yeah, that's a factor. It's not the greatest one.
I don't know then.
You got it. You know, you can do it, man.
Um, 3, 6.
No, it's not a number. It's a letter.
3h.
Well, there's more than one H in here, homie. What's the most H's I can take out of both of these?
3h to the 6th power.
3H to the, I can take 6 out. Thank you so much, Eric Jones. So this becomes H cubed, because 3 divided by 3 is 1. Take out 6 H's. And 192 divided by 3 is 64. And that's it. Okay, now factor this using the difference of cubes. Using the difference of cubes, which is, by the way, a minus b times a squared plus ab plus b squared. Okay, I'm going to come back. I want you to have a full answer there. Factor this out as the difference of cubes. Oh, but before we start, let me ask you a question. What is my a and what is my b, do you think? What is my a and what is my b? Let's go with Giselle. What's my a? What's my a for this? For this, right? What's that?
Would it be h cubed?
The a is not cubed, so what would it be?
3h to the 6th?
No, Giselle, look. For this one here, my a was, this was x cubed. My a was x. Got it?
So would it be 3 or h?
Which one? Give me one of those. It's one of those. One of those is correct.
H?
Yes, a is equal to h. B, what is my b? Okay, you got to take the cubed root of something. Let's go with Camilo. What is my b for this? What is my b here?
4.
4. Thank you so much, sir. Okay, I'm going to give you guys like 1 minute to factor that now that you know the A and the B. Go. You should be done by now. I'm watching you guys. I'm watching. I am looking at you guys. Oh, he stopped sharing. I'm looking at you guys, watching you study and see who's ever not writing, I probably will call on. Is Max's camera working today? Yeah, there's Max. Okay. "20 seconds. I'm calling on you. If you're not done, you have to show me what you have on your paper. You got to show me. How do you solve a problem like that? Okay, 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2. Kimberly, what'd you get?
I didn't finish. I don't understand.
Okay, show me what you got, Kimberly. Let me pin you up there so I can see because my eyesight is so bad. Wait, hold it still. Bring it closer. Okay, x plus 4. Wait, well, first of all, we have an h. Okay, but that's okay. It's okay. There's just a little x squared minus. Well, you're good. That's good so far. Okay. You just need that last one, Kimberly. Be confident. Very good. But I want a full, complete answer. Let's go with Michael. What'd you get, Michael? You can just tell me. You want to show me whatever you want, man.
I got x minus 4 times h squared minus plus 4h plus 4 squared.
What's 4 squared?
Huh?
What's 4 squared?
What do you mean?
Well, what's 4 times 4?
Oh, 16.
There you go. So yes, however, Michael, I would change it just a little bit. First of all, you are correct when you say it's h minus 4, right? Times h squared, square the h, plus 4h plus 4 squared would leave us 16. Don't leave us because you can simplify that. But don't forget because I will mark it, I'll give you only partial credit for that answer. Full credit, you need 3h to the 6th. You need that out there too, because that's part of it. Don't forget that. Which I know you just thought, oh yeah, I remember that. All right, cool. Let's move on. That was 17, 19, 21. Just correct the error. Oh, okay. 21, you can't, that is not the difference of squares. It's the sum of squares, and there you can't factor that. So does anyone need me to explain that better? Because I'm just going to move on. Okay, let's look at 25. Factor the polynomial completely. Ooh, this one might be kind of weird. 25. Can you guys see what I got here? 3a cubed plus 18a squared plus 8a plus 48. Okay. Well, see example 3. I think we look at the greatest common factor here. Let me double check to make sure I'm doing this correct. Example 3. Oh, yeah. Okay. So first we find the GCF. Well, let's just look at this one. When we have 4 of these, this is kind of an interesting thing that they have here. Okay. So what you want to do is let's split it up into 2. They're still together, but let's split it up into this one Just look at that one. And then let's go ahead and look at this one. Because they all, I mean, I can factor out I can't factor anything out, but I can factor something from separate these if I just factor these out. 3a cubed plus 18a squared. They're both divisible by GCF, greatest common factor, is 3a squared. I should have made that order. Hang on. Since I haven't read, I'll make it red. So that's 3a squared. If I factor that out, that'll be a plus 6. That's the red. Now the orange, so we're adding to that, bring our plus down. What's our greatest common factor there? Well, we have an 8. And this becomes a plus 6. Okay, now notice how they both have an a plus 6. The best way I could describe this as is we can write our final answer for this thing as, because what I can basically do, and I'm not going to write it this way, but I can factor out an a plus 6. So let's factor out, like if I said, like, let me do one on the side here. If I said 8x plus 7x, well, I can factor out the x and say x times 8 plus 7, even though I can add those. But I can factor that x out, right? Well, here I can factor out, since these, like, imagine this is both my x's. I could take both of those out and say a plus 6, that's like my x, I take it out, times 3a squared plus 8. And that's it. That's how you'd factor it. So in other words, you just add these and put this, boom, you just kind of say, you know, put these together and just bring the a plus 6 to the side. That's 25. Are there any questions on that? They're all like that. 25. 29 is the same. So do that. You can do that on 29. And $33. So 33, I guess, I mean, oh, 33 is kind of interesting. Should I do 33? How am I doing here? Let's see. You guys see 33? I don't know. Let's see. I think I could just, I'll do 33 very quickly. 33, it's not, 33 is not that weird, not that hard. I mean, it's not that hard if you can do regular factoring. If you can factor a regular trinomial, 9c squared plus 20. Okay, you know what that is? Notice, you're all, wait, it's c to the 4th. Well, could you factor this? C squared plus 9c plus 20. If I was to factor that, I would just go, hey, 29. What times what equals 20 and adds to 9? 5 and 4. So it'll be c plus 5 times c plus 4. Okay, let me know if I'm going too fast. I'm assuming you know how to do this. So instead of, see how these are the same, except this is second and this is to the 4th and this is c to the 1. I just double those. Well, the answer is going to be the same. I just double my c's. C squared plus 5 times c squared plus 4. That's it. It's just the same. It's just that since I double this, I double my c's. That's it. That's it. And I'm putting you to sleep, I know it. 37 is the same. So the last one, 37, 39. Okay. Determine whether the binomial is a factor of x. Okay, determine, okay, I have here, it's 39. Determine whether the binomial is a factor of x. Okay, so the way we figure out this, if it's a factor of x is we use just synthetic division. If it divides and it becomes 0, we know it's a factor. If it doesn't, then it's not. That's it. So let's go ahead and do 39. 39, to determine if it's a factor of x. F of x equals 2x cubed plus 5x squared minus 37x minus 60 And then we say x equals -4. You do synthetic division. If it becomes 0, then we know it's a factor. Okay, so synthetic division, let's set it up. Hang on a second.
Wait, don't you have to do 41? Or are you just doing that one for practice?
30. I did 30. Wait, 33. Oh yeah, I can do. It's the same thing. Yeah, I'll do 41. Yeah, I guess I'm supposed to do 41, right? I'll do 41. It's the same thing. Is 41 the right one?
Oh, okay. Yes, yes.
Okay, so 41. I'll do 41. Fine. I gotta write it all over again. Oh. I know. Okay, I know I need to be patient with them. I know it's right. You're right. It's my job, right? Okay. That's what I said. Yeah. Hey, you're supposed to be just setting up my equipment and stuff, so don't worry about it. No? Okay. All right, Ivan, I'm sorry. Ivan, I'm sorry. Oh,
It's
6x.
okay. Nah,
It's really no big deal. 15x, just writing the whole problem again. 15x to the fourth minus 9x cubed. Okay, so is x plus 3? No, this is supposed to be x minus 4. Is x plus 3 a factor, right? So what we're going to do is we're going to take a -3. We're going to go like this. We're going to go 6, -15, 5, 4, 3, -9. But we also have x squared. X squared, we need a 0, x, and then the number. So I have to have my zeros because in order to do synthetic division, I need x to the 5th, x to the 4th, x to the 3rd. This will be plus, if I was to rewrite it, it would be plus 0x squared plus 0x plus 0. You need your number too. You need all those. 0x squared plus 0x plus 0. And then you just do your synthetic division. If you end up with 0 here, it's factorable. If not, then it's not. So I want you guys to go ahead and factor that out or do your synthetic division. I'm going to watch you and see what you got. Synthetically divide that because I feel like I'm just lecture. I know this is lecture time. It's probably killing you guys. Go ahead and use synthetic division to just synthetically divide that and see what you get based on what we did yesterday. Synthetically divide. I'm watching you. Who's ever not working, I'm calling on you. If your camera's off, I'm for sure going to call on you.
wait, so how do we determine if it's a factor?
You synthetically divide it and see what happens.
And if we get what type of result, then what's
Just synthetically divide it. Ah!
okay. Okay.
See what happens. This is like I'm like Yoda right now. You just need to trust your feelings, Ivan. Just trust them. Oh, this is getting ugly. Ivan, this was an ugly one. I wish we should have done 31. 39. I think. I don't know. All right. What was your last number? Anyone need more time to figure out what the last number was? Let me make sure my answers are right. This ended up being. I want to check something real quick. Yeah, it's not. Okay. So, all right. Here's what I got. Now you see what I got there? My last number is just like a 0. So it's not a 0. It's that. So that's how you know. Do you see it? It's very important that you can see what I wrote here, right here. What I wrote here, this is what you have to make sure that you did this. It's imperative that you make sure that you did this. If you didn't, it's like everything that you do, it's like you might not as well even taken the class. So this is it. Okay, so I'm going to erase this really quick. So make sure if there are any questions before I take this out. Okay, cool. No questions on that? Okay, so make sure that you understand this concept right here, okay? All right, no one else needs this? Okay, let's go ahead and move on, okay? So if you don't understand this concept, it's over. It's over, okay? Might as well not even be taking this class. So, okay. That's it. I'm moving on. Okay, let's go to the next question. Here we go.
Mr.
Okay,
Sanchez.
next question.
Mr. Sanchez.
Yes, I don't really have time for your questions right now. I just want to move on. Okay, so don't worry about it. Everything's all good. Okay, so moving on. I'm just joking. There it is. I was just joking. I knew you guys couldn't see. Is that cruel? Was that cruel of me? Oh, did I lose everyone? No, I played a joke on everyone. Now no one can see me. Hello?
Yeah, we can.
I can't see you guys. Okay, Ivan, you can see me. Let's see. Madison, are you there?
Yeah, I'm here.
Okay. Oh, wait, you guys are here. Okay, anyway, I was playing. I knew you guys couldn't see. Let's see what happened on 41. Okay. So 41 is 6, -15, -9, 0, 0, 0. I think I calculated this out because it gets real ugly, right? Bring the 6 down, multiply by -3. -15 plus -8 is -33. Times -3 is positive 198. Minus 9, I get 189. Times -3, I get -567. Plus 0 is -5. But see these numbers, how they get bigger? This last number should be 0. If it's 0, then yes, this is a factor. Okay? But it's not 0. It's -5,103. Did anyone else get that? I feel like, I hope I didn't make a mistake there. There's
The -3 times -33 is not 198.
It's
I don't
not?
think. It's 99, right?
Well, maybe
It still ends up the same,
33
right?
times 3 is 99. Oh, okay, let me try this again. What, did anyone get 0 then here?
No, it's still a big number.
It's still a big number. Okay. So anyway, this should be 0. If it's not, it's not a factor. If it is 0, then it is a factor. Basically what it is it's divisible. If you can divide it, that means x plus 3 is perfectly divisible by it, and it's one of the factors out. That was 41. Let's do, was there another one I could do there? It's 45. Maybe I'll do another one after class if you guys want to find one that does equal 0. Let's see. But what are we going up to? We're going up to, now I lost my notes. I'm all verklempt here. Up to 61. Let's see if we need anything. I'll see 45. Is 45 next? 41, yeah, 45. Show the binomial is a factor of f of x, then factor completely. Okay, so this one also does is synthetic division. Okay, so 45. Let's see if it's find a factor and then factor complete. So it's the same thing. We'll continue with 45. 45. Do I have room here? Show the binomial is a factor of f of x, then factor completely. Okay, so f of x equals x. What time is it? 11:09. X cubed minus x squared minus 20x. And then we have x plus 4. And we got to add our zeros here, right? So let me continue this. So can you see both of them? You see, I'm right at the top here. F of x equals x cubed minus x squared minus 20x. But let's do plus we got to do 0 because we need the 0 there, right? To see if it factors completely. So is x plus 4, prove that it's a factor. So if it ends up being 0, then it's a factor. So we want -4. We want 1. We want -1, -20, and 0. I'm just going to factor it out because I feel like time's going so fast. You guys are probably ready to get out of here. 20. Okay, see what happened there? 1. 4 times 1 is -4. -4 plus 5 is -5. -5 plus -5 times 4 is 20. 20 minus 20 is 0. Okay, so I don't need this in here because it ends up being 0. So if it's factored out, then I know if it's 0, then I know x plus 4 is a factor. To factor it completely, I would go like this. X plus 4 times, okay? Remember, this was x cubed. So now this becomes x squared minus 5x. And then we don't need the 0 there. And to factor it completely, all we have to do is I can factor out an x here, right? So I say x plus 4 is a factor. Then this is, whoops, sorry, let me write it right here. X plus 4 is a factor. I can factor out an x, so that is x times x minus 5. And to factor it out completely, let's bring this x here in the front and say x times x plus 4 times x minus 5. And that's it factored completely. That was 45. We're going up to 61. So that's all that for 45, 49. Sorry, my phone is blowing up. Silence my phone. I apologize. I'm not looking at my phone. It's just blowing up. Okay. 45, 47, 49. You guys can do all that. 53. Match the function with the correct graph. Explain. Okay, 53. All right. 53. Watch 53. I'm almost done here, guys. I feel like I'm sorry. I know you guys must be dying. You guys are doing great. If you're falling asleep, I don't blame you. I blame me, but try to stay awake, okay? Let's look at 53. Let's look at 53. 3.4. Okay, 53. Hang on, it's coming. 53 is coming. Okay, 53. So what does this match with? Okay, so if you look at 53, my zeros where it crosses the x-axis. Does anyone know what my zeros are where it crosses the x-axis? How do I make this 0 here, right? And that's y equals 0 where it crosses the x-axis. So here on 53, my zeros, 53, my zeros, h of x, my zeros are h of x equals x plus 2 times x plus 3 times x minus 1. Okay, here are my zeros. Okay, what are my zeros? I'm going to ask one of you. I know I could. Where's my? What are my zeros there? Okay, let's go with Samantha. What are my zeros here? I know if you don't know it, it's okay. It's kind of a weird question. I'll ask someone else if you
Like
don't
for
know.
the coordinates, like -2, 0, like that?
Yes, that's exactly right. In order to make this 0, and I would just say, all you have to say, yes, it's -2, 0 is the x-axis. It's just basically my zeros are -2, because will make my y 0. Very good, Samantha. My other one is what? What's my other one then? Samantha?
-3. Oh,
-3, right? Because -3 plus 3 is 0. And then what's my last one?
1.
1, right? Does everyone understand that? Those are my zeros. So I have, it's going to cross at -2 comma 0, because I plug in -2, my y is going to be 0. It's going to be -3 comma 0, because when I plug in -3, my y is going to be 0. And it's going to be 1 comma 0, because when I plug in 1, my 1 is going to be 0. Why are you telling us this, Sensei? Why are you telling us this? I'll tell you why I'm telling you this, because it wants you to match the graphs. So you can see, let's see, wait, hang on, where'd my lesson go? It disappeared. All right, fine. What are my zeros? Wait, did it just, let's go like this. Okay, where are my zeros? Now, I lost the problem. Now I have to find it again. It's 53. Where are you, 53? 53. Okay, 53. So remember my zeros, okay, I'm going to go show you again here. My zeros are -2, -3, and 1, right? So you find the graph where it crosses -2, -3, and 1. So I go here. Okay, -2. This one crosses at, this one's -2, right? -2, because these are 4s. But it doesn't cross at negative. Does it cross at negative? Oh, -3 right there. And +1. It's that one. Wait, let's see this one. This one crosses at -2 and 0, not that one. This one crosses at -2 and 0, not that one. This one doesn't even cross at -2. So it's A. So 53 goes with A because it crosses at -2, -2 here, -2. It crosses at 1 because it's going to be between 3 because I got a +1. And then -3, which is here, -3. All right? 53, 55, I think. So 57 through 61, just factoring completely. I think, guys, that was a long time. I'm sorry. But are there any questions before I let you go? You just did a lot. Basically, we did like 2 weeks of lessons in a day for like math 2. But are there any questions before I dismiss you? I'm sorry, you guys have been great. Are there any questions? I know you guys look dead. I'm sorry, I killed you. So you blame your third period teacher, say Sensei made me sit in the front of the camera for like over an hour. I know, that's what I tried to go as fast as I could. Listen, you want to try this? This is a hard job. It's actually not that hard, but it's hard for them. It's hard for you guys. Okay. So sorry, my assistant's giving me attitude there. So anyway, you guys can go. If you need to stay, you can stay. Bye, Max. Bye, Camilo. Thank you for waiting. Irvin. Bye, Irvin. Bye, Ivan. Bye, Giselle. Bye, Michael. Bye, Annika. Seth. See you later. Jade. Emily. Samantha. Viela. Bye, Viela. Bye, Isaac. Bye, Madison. Bye, Virginia. Bye, Ishi. Bye, Sienna. Bye, Alexis. Remember, no class tomorrow. No class tomorrow. Bye, Ariana. All right. Stromer and Eric. Oh, Eric, let me mark you here, okay? Then you can go.
Okay.
Don't go till I mark you here, just so you know that so you'll feel okay. I'm good. Eric, you're good.
All right.
All right, man. See you on Monday.
All right. See you Monday.
Okay, take care.
You too.